All right, so sorry about last week's air pollution. I just went at the link, looked at the link, and noticed that the audio got deleted. So let's try it again. I'm not using the webcam as well because that slows down upload. So the content on air pollution is they want you to be familiar with layers of the atmosphere, smog, acid rain, CFCs, climate change, global warming, which we'll go over again next week, particulates, and indoor air quality. So let's bust through this. First of all, one thing is they often ask about the difference between primary and secondary pollutants. Primary comes directly from a source like smokestack, exhaust pipe, wildfire, whatever. Secondary is the result of chemical reactions from primary pollutants. Photochemical smog, so you know, is a mixture of both. Last year when they had the question on photochemical smog and I took a test to see how I would do, I got that wrong, even though I've been teaching everyone for 10 years. Photochemical smog is a mixture of primary and secondary. You don't check your beans because you're not in the classroom. So atmospheric basics, the only layers of the atmosphere that matter for the AP exam are troposphere and stratosphere. The only thing that happens in the stratosphere is the ozone layer. And just so you know, the layers of the atmosphere are separated by changes in temperature. It wasn't just scientists like said, okay, we're going to declare this the troposphere. In the troposphere, as you go up, it gets colder. In the stratosphere, as you go up, it gets warmer. In the mesosphere, it gets colder again. In the thermosphere, it gets super hot. The exosphere is when you no longer see a change in temperature. The only two layers for this class are troposphere and stratosphere. The main gas in our atmosphere is nitrogen. Do not refer to nitrogen as an air pollutant because there's already a lot of nitrogen in our atmosphere. To truly boot air pollution, it's got to be something that's not part of our atmosphere's normal composition. So be careful referring to CO2 as an air pollutant. Changes in CO2 would be an air pollutant, our current increase, but on its own, it's not truly an air pollutant. So the major atmospheric gas that we have is nitrogen. And by the way, you can see the layers of the atmosphere as they refract light. So the only thing that happens in the stratosphere is the ozone layer. And another thing to know, ozone down here is bad. It leads to photochemical smog. Ozone up here is good. We can't get the ozone from here up there. Over millions of years, some of it might migrate up there. The ozone layer was actually the result of both photosynthesis and lightning strikes was what produced the ozone layer over the course of billions of years. Also, just so you know, everything is done by convection and movement in the atmosphere. Hot stuff rises, cold stuff sinks. So let's get started with air pollution. By the way, in the old days, we thought if the air pollution was bad, we would make the smokestacks higher. I already gave you the scale of the Earth's atmosphere. Going back to it, though, the troposphere, which we live in, is not very big. It's 14 kilometers. And we can't even survive in most of that. Like Mount Everest would be right around here, and that's about as high as we can go. So one way to think about our air pollution is if you look at a globe, the shiny layer of paint that makes the globe shiny is the equivalent of the Earth's atmosphere. So there's a lot of us farting in a really small tent, and every year we're farting more with more people. So now, first let's do acid rain formation. The key thing you know is SOx and NOx forms acid rain, SO2 and NOx. You can just call it SOx and NOx. Just remember SOx and NOx. SOx reacts with water to form sulfuric acid. NOx reacts with water to form nitric acid. The reason why it's an environmental problem is it can damage root development on plants and trees. This forest looks a little bit stunted because it had rather acidic rainfall. The rain, just so you know, is not acidic enough to burn you. It's not that acidic at all. It's only about a pH of 5 compared to normal rain, which is a pH of 6. And the other thing to know is like the carbon or the sulfur and nitrogen that's produced in Detroit is landing on the East Coast. The stuff that's produced in Minneapolis and Wisconsin is landing in Detroit because it's following major wind patterns. Economic impacts are what people usually mention. Things like marble buildings dissolve. Usually statues originally had noses. This one got eroded off. Michelangelo's actual David is hidden it's inside the Uffizi Gallery. It used to be outside. They've moved it inside to protect it from acid rain. The Statue of Liberty had a major rebuild in the 1980s because all the acid rain was dissolving away the copper plates as well as some of the rivets. Steel bridges and landmarks, but these are all economic. These are not environmental impacts. We talked about this with the lake experiment. It also affects lakes, rivers, and forests. Forests have trees have a fungus on their roots called mycorrhizae that helps it absorb energy. So forests or help them absorb minerals. Acidic rain causes impeded root absorption, which can have major problems. It also releases aluminum, which makes soil even worse, or it makes problematic things. But the other thing is it can make chemical pollution worse because acidic water tends to dissolve more heavy metals. And we already talked about the trophic cascade. Smog, we got two types. We got the industrial smog and the photochemical smog. And so these two types of smog, we're going to go over individually. Photochemical smog is often called brown air smog. That's what we have in Fort Collins. It's a modern smog. It's a mixture of chemistry and light making it worse. Industrial smog is the deadly fog of history that they often talked about, places like London and New York where they were burning so much coal that people were getting sulfuric acid burns inside their lungs. So industrial smog kills you fast. Photochemical smog kills you slow. Here in Fort Collins in the Front Range, we have a major problem with photochemical smog. So the killer fog of London and New York City, that was from burning coal in small fireplaces in people's homes. Photochemical smog is a mixture of primary and secondary pollutants. So think about it as both the ingredients and the cookies you make combined to make something super toxic. Light is required for the reaction, which is why it's called photochemical smog. And there's no single ingredient in photochemical smog. There's hundreds of different things that we're finding. Photochemical smog is often measured just by ozone level, but there are tons of compounds within it. So let's make photochemical smog. By the way, this is a clear sunny day. If you go online right now, you can see pictures with no one driving or going anywhere because we're all stuck at home. You can see air quality is rapidly getting better because of the major contributions we had to photochemical smog. Our car exhaust is no longer a thing. In this picture, you see two suns because of refraction of light. There's so many chemicals in the atmosphere that make up photochemical smog. It's bending the light to give a second sun over the city. So the key for the exam is you have to know the inputs. So there's only two inputs humans have: hot car engines and VOCs. Those are the only inputs. So the first step is a hot car engine will combine nitrogen and oxygen to become nitric oxides under high temperatures. This is done primarily with car engines. Electric cars, by the way, don't have as hot of an engine, which is one reason why a lot of places are encouraging switching to electric cars. Step two requires water vapor. Humans don't even add the water vapor, it's just in our atmosphere. So NO2 in water forms nitric acid and NO. Step three gets crazy. And I know these are going fast, but you can pause and rewind and say bad words about me. NO2 reacts with sunlight to form NO and O. And O is unhinged. It's like that weird person in your class that you don't want to give caffeine and a puppy to because they will explode with bizarre emotions. It's called a free radical. Oxygen atoms react with O2 to form ozone. O and O3 react with these other things called VOCs, volatile organic compounds, to make aldehydes. So here is the weird thing. The only thing that's required for this stage is sunlight. The other thing is this is our other human addition, VOCs. VOCs are not, people often think volatile means explosive. Volatile means evaporates quickly. It just so happens if you're a volatile organic carbon, you tend to also be pretty flammable. These are things like oil-based paints, turpentine, paint thinner. Their sources include paints, plastics, dry cleaners, gas stations, oil refineries. Here in the Front Range, fracking is a source of VOCs because it's outgassing volatile organic compounds. Aldehydes, just so you know, if you are a carbon chain, R stands for carbon chain with an oxygen double bonded at the end. A famous aldehyde that you've probably heard about is formaldehyde, which we're not allowed to have in any school anymore because it's super cancerous. Often when people talk about photochemical smog, they refer to it as cigarette equivalents for different cities. Here in Fort Collins, because we're sunny and we're high elevation, so we have a lot of UV light, and we're in a little bit of a valley against the mountains, we have high photochemical smog. And some days here, it's the equivalent of smoking a half pack of cigarettes just living in this town. But anyhow, I digress. Step four, everything reacts with everything to produce peroxyacyl nitrates called PAN. So on the AP exam, you could refer to ozone as a secondary pollutant. You could refer to PAN as a secondary air pollutant. But since photochemical smog is a mixture of those as well as primary pollutants, you can't call that a secondary air pollutant. And the issue with photochemical smog is, well, first of all, it gets worse with sunny areas, which is why Fort Collins is a problem, and Denver. If you go out to 25 on a clear sunny day and look at the mountains, you'll see a brown haze often blocking the Rockies, and that's photochemical smog. It increases during the morning commute as cars make NOx. It also increases in high elevation cities and sunny cities, or LA. New York City doesn't have as much problem with smog because they have a coastal breeze. LA is in a superheated valley. Another thing to know is, oh, by the way, look at that brown cloud of ugliness. Smog doesn't stay put, it moves in the wind. So there's some more smog. There's some smog blowing across the Adriatic Sea. By 2050, 400 million residents of China will be driving cars as their economic plan. That could cover the entire Pacific Ocean with smog. The US can't say much because we have a higher rate of car ownership per capita than China, and we drive more miles. What China is doing is investing in electric car technology and public transportation. Now, the issue with photochemical smog is it causes increased rates of asthma, bronchitis, COPD, which is obstructed pulmonary disease. And it even increases your risk of lung cancer. So overall, it also increased rates of asthma attack. One of the highest rates of asthma in the country is in Greeley, Colorado. And one reason why their photochemical smog level is so high is because of all the fracking that's outgassing VOCs in that region. Industrial smog. This just sulfur dioxide forms droplets of sulfuric acid on the water on your lungs because your lungs are wet on the inside. It's that. And then that. What makes smog worse is thermal inversions. Normally, as you go up, remember in the troposphere, you have warm air, cooler air. Sometimes you get a warm inversion layer. These often happen in valleys. It's often related to humidity. So in Fort Collins, sometimes you'll get alerts about air quality, and that means that we have an inversion layer. And that's like crowding a bunch of people into a tent, zipping it shut after everybody ate a bunch of beans. Only it's not just farts, it's toxic things, including photochemical smog. That's one reason why, like Yahoos, like the doofus who rolled coal on me 2 days ago on Oak Street, I was not only annoyed because that's making asthma problems worse for people, but that stuff he outgassed from his car is going to be lingering here for the next few days. Fortunately, right around that same time, I reported his plate, so he'll be getting in a surprise emissions test next time he renews his tabs, which, just so you know, you can do that online. Here's an inversion layer that was pretty light, and it got punctured by a small backyard fire. The inversion layer is the little thin layer of clouds. So there's an inversion, which basically it's just like putting a dome over your town. Other air pollutants that they like to ask about in the AP exam is mercury, which comes from burning of coal. Lead, which we usually don't have too much anymore because it's been banned from everything. The main source of lead was gasoline as an additive because it kept engines from knocking. In the 1990s, we phased lead out of gasoline. If you're incredibly bored, there is a really good episode of Cosmos talking about Claire Patterson, the scientist that testified to help get lead removed from gasoline. Because here's the weird thing, all of you have significantly less lead in your body than someone my age or older. As a result, you are smarter. Usually, mostly. Yes, you're smarter. Dioxin is another air pollutant. It comes from burning of plastic. These two are heavy metals that cause kidney problems as well as nervous system problems. Indoor air pollution, we talked about briefly. One of the big solutions with indoor air pollution is open your windows. Just open your windows, and if you're going to do home renovation, make sure that you have things tested for asbestos. Get your water heater serviced by someone who knows what they're doing, and check your house for radon. So the reason why air pollution inside never used to be a challenge was because in the old days, our houses were so drafty, not much got stuck in there. But now our houses are sealed pretty tight. So these are all the things that can kill you in your house, which is kind of creepy. All right, so by the way, my parents nearly killed all of their children with a kerosene space heater that they kept on the porch for family ski trips, because when there were a lot of people going on a ski trip to their vacation home, there wasn't enough rooms for all of us. So we would all the kids would sleep on pull-out couches on the porch that had no heat or insulation. So to keep us warm, they would burn a kerosene heater. They never understood why we kept getting sick and were cranky with headaches and like mopey every time we did that, until one time they slept out there and realized they were poisoning us with carbon monoxide. But I digress. So wood stoves release particulates. Foam, all these things, foam paddings and curtains and plywood, all outgas VOCs. Mothballs are VOC. Fresh dry cleaning, which is what old people do with their clothes. Best thing to do if you're going to get your clothes dry cleaned is actually move them into the garage or hang them outside and take the plastic outside. Everything creepy in your basement and garage on the shelves that you're told to get away from. But now let's talk about radon and asbestos. Oh, by the way, hold up. Carbon monoxide, by the way, the major source of carbon monoxide is improperly burned fossil fuels from your water heater and furnace. That's why you should get those serviced regularly. So there we go. Get those appliances serviced regularly, especially if you're an idiot nerd like myself who doesn't know how to service them. You should also get a carbon monoxide detector in your house. Radon is one of the biggest causes of lung cancer after smoking. Now that fewer people are smoking, radon will probably eventually become the biggest cause of lung cancer, although you all discovered vaping, so you've probably brought tobacco back as one of the dangers. Radon comes into your house through things like plumbing fittings, as well as holes in your foundation, as well as microscopic cracks. It can even outgas through older, thinner concrete. So when radon gets into your house, and it comes from the decay of radioactive material in the soil, primarily uranium. So as it decays, it releases radon, which is an invisible odorless gas. This never used to be an issue because no one used to live in their basements, but now everybody's renovated their basements into man caves and teenage bedrooms. So now everybody's sleeping in giant clouds of radon. The way they have to fix radon is radon abatement. If you have a house with radon in the basement, what they have to do is they have to cut through the concrete slab, put tubes connected to a air pump here, a fan that sucks the radon out here, and the goal is to make the air go from your basement out into the foundation. Changes the direction of airflow so that the radon doesn't go up this way. Instead, it gets sucked out that way. If your house is already there, it can be $10,000 to $25,000 to do it. Because our house was a piece of crap and collapsing, we had to tear it down, which, if there is no house there to put on a radon abatement system, is only about $1,000. Particulate matter is anything that can get into your lungs and cause a problem. Smoke is considered a particulate matter because it's soot. So just so you know, smoke is particulate. Pollen is particulate. This is pollen right there. Some of the most dangerous ones, though, are things like mold and asbestos, especially asbestos. Here's a microscopic picture of asbestos. It's tiny little sharp fibers, and we used to use it for everything because it was mold-proof and fire-proof. So we're like, excellent. Asbestos is a mined material. This is what it looks like. That little fluffiness, which looks like, I know you all want to play with it, don't play with it. It causes the same kind of damage as smokers' lungs. Because the asbestos fibers get into your lungs and you can't get rid of them. And every time you breathe, it's making microscopic tears that then become scar tissue, which makes it harder to breathe. It's called mesothelioma or asbestosis. And if you get it, you can get it with clay dust as well, and that's called silicosis. And the thing is, there is no fix for it when you get it, so you have to not get it. And the thing with asbestos is we put it in everything but the carpeting in houses. You can find it in some houses in the drywall compound, in the outdoor siding. You can find it in roof tiles. You can find it in ceiling tiles. You can find it in the floor tiles if they're linoleum. You can find it in the glue that holds on the tiles. You can find it in the grout or even the mastic that goes underneath the tile. You can find it in the cement board. It is just about everywhere, including the insulation. So if you're ever doing, the thing is, it's safe unless it starts flaking off, which is why before you do home renovation, you should have it tested for asbestos. Clay dust is another one, and clay dust includes any silica dust, including from cutting of rocks. That's why you should always cut tile with a wet saw, so you're not making clay dust, because there is no filter that will protect you from clay dust. Catalytic converters are one of the solutions for car exhaust. Just, we'll talk about some quick solutions and then we're done. I'm so sorry again that the last time this didn't work. Catalytic converters remove carbon monoxide and hydrocarbons from your car exhaust, as well as NOx. We started putting these on cars in like the 1980s, I believe. Scrubbers are put on factories. They're used to reduce dangerous products from smokestacks, especially mercury as well. So we'll skip that. So here are the big things to do. Scrubbers can also decrease SOx and NOx, so they fight acid rain. Catalytic converters reduce carbon monoxide and hydrocarbons coming off gas tanks. Like my old 72 Cutlass I used to drive in high school, which was my dad's. It's a beautiful car, and I used to love the smell of the exhaust because, well, it turns out it was partially burned gasoline because it didn't have a catalytic converter. The other thing to note is bag filters can remove particulates. Electrostatic precipitators can remove particulates. On the AP exam, don't just say, put a filter on it, because we don't have a filter for everything. So an acid rain, here are the environmental impacts of acid rain. Normal rain is pH of 6. Acid rain is lower than that, around pH of 5. These are the ecological impacts of it. It damages root mycorrhizae. As you saw with the acid rain lab that we did, the seeds didn't grow so well in vinegar. It releases aluminum from the soil, and that aluminum becomes toxic to plants. So here are the solutions to acid rain. Burn less fossil fuels. Use scrubbers. Remediation, you can add lime to water bodies that have become acidic. Lime is powderized limestone. Remediation also includes biological buffering. Some bacteria neutralize acid. Just know there's not a filter for everything. Solutions for photochemical smog are public transportation, especially light rail, because those are usually electric trains that don't produce the NOx, as well as VOC reduction. Dry cleaners and a lot of construction companies have decreased the amount of VOCs they're producing, which is great. Sadly, fracking is increasing the amount of VOCs we're producing. So, noise pollution, we might as well cover noise pollution. Noise pollution, for humans, it causes increased stress and hearing loss. For wildlife, it causes problems with predator-prey interactions. It can change nesting behaviors. And you can even get noise pollution under the water. Things like sonar are causing whales to beach themselves because it's screwing up their navigation. Now, this time I remembered to record audio. I'm so sorry about last week. I miss you all. Except for Alex, because, she's mean to me. Alex isn't mean to me.